Hello everybody, welcome back to the first video of Modular Arithmetic Part 2, that is Euler's Theorem. This is Part 2 in the sense of second semester I'm talking about. So, we're talking about Euler's Theorem, chemistry cycle basically. So, first topic we're discussing in this chapter is Euler's Theorem. I will not explain a detailed procedure, I will just tell you the main formula which is required is a power phi n is congruent to 1 mod n. And this phi n you can find out by n into 1 minus 1 by p1, 1 minus 1 by p2, so on. P is prime number, p1, p2 is prime number. When I want to use this, GCD of a comma n is 1. Okay, it starts like this. GCD of a comma n is 1. They means basically they are relatively prime. Okay, they are relatively prime. So that's what it means. Now directly into the question we'll go, and then we'll start solving. So let's go to question number 1. So basically using Euler's theorem, you have to compute or find the remainder, both are same. I read the question 2 power 666 mod 77. One more thing I would like to say before we start to solve, keep your calculators ready with you because it's very essential. Now 2 here is basically n and this is n. GCD of 2,77 is 1. So a power phi n is congruent to 1 mod n, correct? So 2 power phi of 77 is congruent to 1 mod 77. And now phi of 77, how will we write? First we have to express 77 in terms of two prime numbers. 7 into 11 we can write. So is equals to 77 into 1 minus 1 by 7 into 1 minus 1 by 11. So phi of 77 is congruent to 77 into 6 by 7 into 10 by 11. 7 ones are 11s are 11 cancel. So phi of 77 is congruent to 60, so is equal to 60. Okay, is equal to 60. Now this we'll put it over there. So 2 power 60 is congruent to 1 mod 77. But what do we need? Do we need 2 power 60? No, we need 2 power 666. So find the nearest number. You can start with 2 power anything also, but I'm going to try to find the nearest number to 666. So 666 by 60 I'll do. What will I get? I will get 11. So 60 into 11 I should do basically. So 2 power 60 to the power 11 I can do because it's going to multiply. That's congruent to 1 power 11 mod 77. This is going to be 2 power 660 is congruent to 1 mod 77. Now this 660, we need 266. So 2 power 660 into 2 power 6 is congruent to 2 power 6 mod 77. So 2 power 666 is congruent to, what is 2 power 6? It is 64 mod 77. So the remainder is 64. That's it, simple. I hope you understood. Let me just quickly recap once. This is going to be your question, this is going to be your a, this is going to be your n. GCD of a comma n is 1, they are relatively prime. The formula is a power phi n is congruent to 1 mod n. Phi n is what? n into 1 minus 1 by p into 1 minus 1 by p2. So then we're going to substitute back into the formula and just evaluate. That's it. Let's go to the next question quickly. Question number 2. Find the last digit of 3 power 30 using Euler's theorem. So when they say last digit, that I have to remember, it is basically 3 power 30 is congruent to 1 mod 10. If they say last 2 digits, then mod 100. Last 3 digits, mod 1000. So here last digit means last 1 digit, so mod 10. Okay, this you understood how we have written 3 power 30 is given in the question itself. So here a is what? 3. N is what? 10. GCD of 3 comma 10 is what? 1. So a power phi n, this is by Euler's theorem is solved. Many ways they are there to solve this. Even in last semester we could have seen many methods. I am telling Euler's method how to solve. Is congruent to 1 mod n. So 3 power phi of 10 is congruent to 1 mod 10. Phi of 10, how can we express 10 as 10 you can express as 2 into 5 is equal to 10 into 1 minus 1 by 2 into 1 minus 1 by 5. 10 into 1 by 2 into 4 by 5. 2 ones are 5s are. So 4. So 5 of 10 multiplied by 4. 3 power 4 is congruent to 1 mod 10. But do we need 4? No. What do we need? We need 30. So nearest second decade is 28. So 3 power 4 into 7 is congruent to 1 power 7 mod 10. So 3 power 28 is congruent to 1 mod 10. So 3 power 28 into 3 square is congruent to 3 square mod 10. 3 power 30 is congruent to 9 mod 10. Therefore 9 is the remainder. That's it. Wasn't it easy? Wasn't it easy? Okay, let's move to the next question. The next question goes like, find last 2 digits of 11 power 84. So 11 power 84. There was last 2 digits, means what? 11 power 84 mod how much? 100 is congruent to 1 mod 100. 11 power 84 is congruent to 1 mod 100. This is how we are going to write it as. Next we have to find, this is A is 11, N is 100, because last two is 100 we have taken. A power 5n, or basically what does this mean? The last two digits of 11 power 84 is remainder when 11 power 84 is divided by 100. That's what it means. Okay. A power 5 is congruent to 1 mod n. So 11 power 5 of 100 is congruent to 1 mod 100. All the sentences I'm not writing, but you can write it in the exam. So 100 we know this is basically 2 into 2 into 5 into 5. How did we write this? Quickly I'll show you. 250s are, I'll do it in the side, otherwise 250s are 225, then 5 5s are 5 1s are. So 100 we got it as 2 into 2 into 5 into 5. But there was P1, P2 prime numbers. They should have been prime numbers. So how are we going to write it as? 100 is 2 square into 5 square. Now 2 and 5 are prime numbers. Now we can write it as that. So 5 of 100 is equals to 100 into 1 minus 1 by 2 into 1 minus 1 by 5. Yes, we can write it like this also. Okay. So 100 into 1 by 2 into 4 by 5. 2 1s are 50s are, 5 1s are 10s are. So 5 of 100, what do we get as? 40. So 11 power 40 is congruent to 1 mod 100. But do we want 11 power 40? No, we want 11 power 84. So what we can do? 11 power 40 whole square is congruent to 1 square mod 100. 11 power 80 is congruent to 1 mod 100. 11 power 80 into 11 power 4 is congruent to 11 power 4 mod 100. 11 power 84 is congruent to, what is this going to be? It's going to be 14641 mod 100. So either you can last digit, so we can write 41 is the remainder, or let me just tell you, in such a case, right, if you want this to be, if you want 14641, if you want this number to be less than this number, right, nothing, just listen to me what I have to do. 100 by 14641, we know what is this going to be? 146 times, so 146, 1 second, yeah, 14600 minus it, sorry, what will get? 41. That is only what we're going to write here. So 41 is the remainder. Either you write the last digits from here only directly, or you do what I did right now. Either ways you will get the same answer. 41 is the remainder. Okay. Next question. Find the last two digits of 3 power 2 2026. This video is doing only Euler's. First point. Second point is last two digits basically remainder. We're talking about the remainder. Okay, the last two digits of 3 power 26 2026 is basically the remainder when 3 power 2026 is divided by 100. Okay, that's how we're going to do that. You have to consciously remember, because just when they give this question you might not understand how to proceed. Okay, so 3 power 2026 is congruent to 1 mod 100 by 100. Why not 10? Because last two digits they have taken. If they would have said last digit, they would have taken 10. Okay, so 3 power, so here a is what? 3, n is what? 100. So a power 5n is congruent to 1 mod n. So 3 power 5 of 100 is congruent to 1 mod 100. Just now we found out 5 of 100. How did we find out? 2 and 5 by taking 2 and 5. So 100 into 1 minus 1 by 2 into 1 minus 1 by 5. If you have forgotten, just scroll back for some more minutes, you will get it. So 100 into 1 by 2 into 4 by 5. So you get 40. So 5 of 100 is 40. So 3 power 40 is congruent to 1 mod 100. Do we want 3 power 40? No, we want 3 power 226. So 2026. So 2026 by 40 if we do, you will get 50. So 3 power 40 into 50 is congruent to 1 power 50 mod 100. This is going to be what? 3 power 2000 is congruent to 1 basically 1 mod 100. So we want 2026. So 3 power 2000 into 3 power 26 is congruent to 1 mod 100. Now, sorry, here also 3 power 26. Now this is this. When there is exponential, because if you do practically 3 power 26, you will into 10 power 12, something that you will get. So when there is exponential, remember, when there is an exponential, when there is a larger number, you have to start like 3 power 8. Start like 3 power 8. For this 3 power 26, this 3 power 226, we have 2026 about 3 power 26 mod 100. Now how to resolve this when there's exponential case? That time for example, take 3 power 8, 3 power 7, 3 power 6, anything you take, anything. Okay, suppose I'll take 3 power 4 and show you. 3 power 4 is congruent to that. Again I have to see 81 mod 100. Okay, 3 power 4 is congruent to 81 mod 100. Now we want 26 but. So 3 power 4 into 7 is going to become basically what? Then I think it's better to start like, okay, we can do like that also, no worries. 81 mod 100. Okay, 3 power 3 and 7 we want, so we get what? 81 power 7 mod 100. Any number you can start, but do not exceed 3 power 9. Don't exceed 3. Do not exceed 3 power 8 basically. Do not exceed 3 power 8, otherwise become too large. So calculator to show we are doing all this, right? 3 power 28 is congruent to 81 mod 81 power 7. Okay, now this also is exceeding. Okay, that's why let's take a larger number and do. This is just an exponential case, otherwise very nicely we were freely doing. It's an exponential case, you have to be a little bit more careful. Okay, let's take 3 power 7 and do. So 3 power 7 is what? 2187 mod 100. This, do you know how to reduce 100? 2187, that's going to be what? 21. So 2100, so that's going to be 87. That's going to be basically last two digits. I'm just showing you how did we get it. 87 mod 100. What did we want? 126. So cube, correct? So 87 cube mod 100 will become. So 3 power 21 is congruent to 87 cube. That is basically 658503 mod 100. Last two digits basically remainder is going to be, so 3 power 21 is congruent to 3 mod 100. We want what? We want 26, correct? So 3 power 21 into 3 power 5 is congruent to 3 into 3 power 5 mod 100. So 3 power 26 is congruent to 3 power 6 mod 100. 3 power 6 is what? 729. 3 power 26 is congruent to 729 mod 100. 3 power 26 is congruent to 29 mod 100. 29 is the remainder. In exponential case, take that part separately, start with a lower number and bring it up to that number. Okay, that's it. Now next, let's go to the next question. If you want to use seat once, pause and see if you have any doubts. Okay, now let's go to the next question. Find the remainder when 2 power 10 is divided by 11. So it's going to be what? 2 power 10 is congruent to 1 mod 11 divided by whatever comes, that is going to come over here. So it a is 2, n is 11. So a power 5n is congruent to 1 mod n. So 2 power 5 of 11 is congruent to 1 mod 11. Now 11, how are we going to write it as prime numbers? In that case, only one we can write. So 5 of 11 is going to be 11 into 1 minus 1 by 11. So 11 into 10 by 11. So 5 of 11 is going to be 10. So 2 power 10 is congruent to 1 mod 11. But what do we want? We want 2 power 10 only. So we got. So remainder is what? 1. That's it. Simple. Let's go to the next question. Question number 6, if I'm not wrong. So 2 power 2003 is divided by 11. So 2 power 2003 is congruent to 1 mod 11, where GCD of 2 comma 11 is 1, all that. And here a is 2 and n is 11. A power 5n is congruent to 1 mod n, and 2 power 5 of 11 is congruent to 1 mod 11. Just now 5 of 11 found out 11 into 1 minus 1 by 11. 11 into 10 by 11. So that is going to be 10. So 2 power 10 is congruent to 1 mod 11. But did we want 2 power 10? No, we wanted 2003. So then what are we going to do? So we get 200. So 2 power 10 to the power 200 is congruent to 1 power 200 mod 11. So 2 power 2000 is congruent to 1 mod 11. But we want 2000, no, we want 2003. So 2 power 2000 into 2 power 3 is congruent to 2 power 3 mod 11. So 2 power 2003 is congruent to 8 mod 11. So 8 is the remainder. That's it. So with this, we have successfully finished the whole of Euler's theorem in under 20 minutes, which is great. So I'll see you in the next one with Wilson's theorem. That's also going to be nice and fun. So until then, see you. Take care. Bye bye. See you in the next one.